Hello, good morning, students. So, in today's class, we will see flow through pipes and in detail about the loss of head due to friction and all. I'm sharing the screen. I hope it is visible to you. So, the loss of energy in pipes when a fluid is flowing through a pipe, the fluid experiences some resistance due to which some of the energy of the fluid is lost. This loss of energy is classified as major energy loss and minor energy loss. See here, when you study this module, it is module 5 flow through pipes. You need to imagine a lot of things. You have to imagine that you are dealing with the water resources at your home. So then you can easily understand this topic. So what we are doing, what we are telling, when a fluid is flowing through a pipe, the fluid experiences some resistance due to which some of the energy of the fluid is lost. जब एक फ्लूइड फ्लो होता है पाइप में से, वो जो फ्लूइड है कुछ रेजिस्टेंस महसूस करता है जिसकी वजह से उसकी एनर्जी लॉस होती है। ये लॉस ऑफ एनर्जी को हम क्लासिफाई करें हैं मेजर एनर्जी लॉस एंड minor energy loss. So this is major energy loss. This is due to friction and it is calculated using the formula Darcy Weisbach formula and Chezys formula. Whereas minor losses in pipes is this is due to sudden expansion of pipe or sudden contraction of pipe, bends in pipe, pipe fittings and obstruction in a pipe. Now we will see what is the loss of head due to friction. That is major loss. Darcy Weisbach formula. So the loss of head due to loss of head or energy in pipes due to friction is calculated using the formula. Darcy Weisbach formula HF equal to 4 FLV square divided by D into 2G, where HF is the loss of head due to friction and F is the coefficient of friction, which is a function of Reynolds number, which is equal to 16 by RE for RE less than 2000 viscous flow, or it is F is equal to 0.079 divided by RE raised to 1 by 4 for RE varying from 4000 to 10 raised to 6. And the L is length of the pipe, V is mean velocity of flow, and D is the diameter of flow. Now you need to calculate Chezys formula. Chezys formula for loss of head due to friction. So referring to the earlier articles, we calculated HF is equal to F dash divided by rho g into P by A into L into V square, where HF is the loss of head due to friction, P is the wetted perimeter of pipe, A is the area of cross section of pipe, L is the length of pipe, and V is the mean velocity of flow. Now the ratio A by P is equal to area of flow divided by perimeter, which is where perimeter is called hydraulic mean depth or hydraulic radius and is denoted by the symbol M. So your hydraulic mean depth M is equal to A by P. Your A is nothing but pi by 4 into D square and P is nothing but pi D. So if you do the calculation, it comes out to be D by 4. Substituting A by P equal to M or P by A is equal to 1 by M in equation 1. On 11.2, what you get HF equal to F dash by rho G into L into V square, or your V square is equal to HF into rho G by F dash into M into 1 by L, or is equal to rho G by F dash into M into HF by L. So your V is comes out to be under root of rho G by F dash into under root of M into HF by L. Let under root rho g by f dash is equal to c, where c is a constant known as Chezys constant, and hf by L is equal to I, where I is the loss of head per unit length of pipe. So substituting this value, what we will get? Substituting the value of rho by g by f dash and rho by hf by L in equation 11.3, we get equation 11.4, that is v equal to c into under root mi. This equation is known as Chezys formula. At C is known as Chezys constant. The value of M for pipe is always equal to D by 4. Now we will solve some problem on this. Find the head loss due to friction in a pipe of diameter 300 mm and length 50 meter, through which water is flowing at a velocity of 3 meter per second using Darcy's formula and Chezys formula, for which C is equal to 60. And take V for water as 0.01 Stokes. That is, kinematic viscosity is given as 0.01 Stokes. So what are the things given to you? Diameter of pipe is nothing but D equal to 300 mm, which comes out to be 0.3 meter. Next, length of pipe capital L is equal to 50 meter. Next, velocity of flow V is equal to 3 meter per second. Chase's constant C is equal to 60. Kinematic viscosity V is equal to 0.01 Stokes or 0.01 centimeters square per second. So it comes out to be 0.01 into 10 raised to minus 4 meter square per second. So the Darcy's formula is given by the equation HF equal to 4FLV square by D into 2G, where F is equal to coefficient of friction and is a function of Reynolds number RE. But Reynolds number R is given by R is equal to V into D by small v. V is 3, that is velocity is 3, diameter D is 0.3, kinematic viscosity is 0.01 into 10 raised to minus 4. So your Reynolds number comes out to be 9 into 10 raised to 5. So using this value, you can calculate F. F is equal to 0.079 divided by RE raised to 1 by 4. So 0.079, RE is 9 into 10 raised to 5 raised to 1 by 4. So it comes out to be 0.0256. So your head loss HF equal to 4FLV square by D into 2G. 4F is how much? 0.0256 into L is how much? 50 into V square is 3 square divided by D diameter is 0.3 into 2 into G is 9.81. So if you calculate, it comes out to be head loss is 0.7828 meter. So the SI unit for head loss is meter. Now using Chezys formula, for which C is given as 60, M is equal to D by 4. So 0.3 divided by 4, if you do, it comes out to be 0.07 meter. HF is equal to V equal to C into under root Mi. V is 3, C is 60, point M is 0.075 into Y. So if you do the calculation, it comes out to be 0.033. But I equal to HF by L. HFL is how much? 50. Equating the two values, we have HF by 50 comes out to be 0.0333. So if you observe it, the loss of head due to friction obtained from Darcy Weisbach equation is different compared to the loss of head obtained from Chezys formula, depending upon Chezys constant. Now we will solve one more problem in which it is given as find the diameter of a pipe of length 2000 meter when the rate of flow of water through the pipe is 200 liter per second and the head loss due to friction is 4. Take the value of C equal to 50 in Chezys constant. What we are assuming? L, length of pipe we are assuming as 2000 meter. Discharge Q we are assuming at 200 liters per second or 0.2 meter cube per second. Head loss due to friction HF equal to 4 meter. So the value of Chezys constant C is equal to 50. So what are the things given to you? Length is given to you, discharge is given to you, loss of it due to friction is given to you, C is given to you. So the velocity of flow V is equal to discharge by area. It is Q by pi by 4 into d square. Q is given to us 0.2 pi by 4 d square. 0.2 into 4 into pi into d square. Hydraulic mean depth M is equal to d by 4. And loss of weight per unit length I equal to HF by L. HF is how much? 4. L is 2000. So I comes out to be 0.002. Now we have Chezys formula as per equation 11.4, which comes out to be V is equal to C into under root Mi. So substituting the values of V, M, I and C, what we get? 0.2 into 4 divided by pi d square is equal to 50 into under root of d by 2 into 0.002. So if you do the calculation, diameter d comes out to be 0.0518. sorry, d raised to 5 comes out to be 0.0518. If you do d equal to under root of 5 times 0.0518, it comes out to be 0.553 meter or 553 mm. So this requires your calculation part. Now coming to one more problem. Sorry. Hmm. A crude oil of kinematic viscosity 0.4 stoke is flowing through a pipe of diameter 300 mm at the rate of 300 liters per second. Find the head loss due to friction for a length of 50 mm of the pipe. So I guess you are unable to see it. I am just sharing the screen once again to reply me whether it is visible to you or not. Hmm. So what is the problem? A crude oil of kinematic viscosity 0.4 stokes. Kinematic viscosity V is given to as 0.4 stokes. So you convert it into meter square per second by multiplying with 10 raised to minus 4. And diameter of pipe is given to you. How much? 300 mm or 0.3 meter at the rate of 300 liters per second. Discharge Q is also given to us 300 liters per second. So if you convert it, comes out to be 0.3 meter cube per second. What you need to calculate, find the head loss due to friction for a length of 50 mm of the pipe. Capital L is given to us 50 meter. So velocity of flow B is equal to Q by area. Q is given to as 0.3. Area is pi by 4 into d square is 0.3. So your V comes out to be 4.24 meter per second. Reynolds number Re equal to V into D divided by small v. Capital V is 4.24 into D diameter is 0.3 divided by dynamic viscosity, dynamic viscosity 0.4 into 10 raised to 4. So Reynolds number comes out to be 3.18 into 10 raised to 4. As Re lies between 4,000 and 10,000, the value of F is given by F is equal to 0.079 divided by RE raised to 1 by 4. So it comes out to be 0.079 divided by 3.18 into 10 raised to 4 raised to 1 by 4. So it comes out to be 0.0591. So now the head loss due to friction, how you will calculate HF equal to 4FLV square divided by D into 2G. 4 F is how much? 0.0591 into L is 50 into V square is 4.25 square. D is 0.3 into 2 into 9.8. So it comes out to be 3.61 meter. So this is also similar kind of problem. We will avoid this. Now we will go to minor energy losses or head losses. Till now what we studied is nothing but major loss. See here major loss, minor loss, why the name differentiation is given. In case of major loss, more amount of water is lost due to friction and which is given by Darcy Weisbach equation as well as Chezys constant. That is, if you use Darcy Weisbach equation, HF equal to 4 square divided by D into 2 into G. If you choose this constant, V is equal to C into under root Mi. Now, minor losses. The loss of head or energy due to friction in a pipe is known as major loss. As we have seen that loss due to friction is termed as major loss, while the loss of energy due to change of velocity of the flowing fluid in magnitude or direction is called minor loss. See here, try to understand the difference between major loss and minor loss. Major loss is nothing but loss of head due to friction. Loss of energy due to friction is termed as major loss, in which more amount of water is lost, and HF is calculated using Darcy-Weisbach equation and Chezys equation. Whereas minor loss, how which type of loss is termed as minor loss and how it is occurring? The loss of energy due to change of velocity. क्या हो रही है आपकी एनर्जी लॉस हो रही किस वजह से चेंज इन वेलोसिटी की वजह से of the flowing fluid in magnitude and direction is called as minor loss. So there are different types of minor loss. First is loss of head due to sudden expansion of pipe. अचानक से अगर पाइप ओपन हो गया तो उसके वजह से जो लॉस हो रहा है उसको हम बोलेंगे लॉस ऑफ हेड ड्यू टू सडन एनलार्जमेंट. नेक्स्ट इज लॉस ऑफ हेड ड्यू टू सडन कॉन्ट्रैक्शन. अचानक से अगर पाइप कॉन्ट्रैक्ट हुआ उसकी वजह से जो लॉस ऑफ एनर्जी हुई उसको हम बोलेंगे लॉस ऑफ हेड ड्यू टू कॉन्ट्रैक्शन. नेक्स्ट लॉस ऑफ हेड एट द एंट्रेंस ऑफ द पाइप. अगर एंट्रेंस ऑफ द पाइप पे कुछ प्रॉब्लम है उसकी वजह से जो एनर्जी लॉस हो रही है उसको हम करेंगे लॉस ऑफ हेड एट द एंट्रेंस ऑफ द पाइप. Similarly, loss of head at the exit of the pipe. Suppose at the exit of the pipe, if there is what you can say loss of energy, then the type of loss is termed as loss of head at the exit of the pipe. Next, loss of head due to obstruction in the pipe. If in the pipe, if any unwanted material like dust, stones is and said is there, due to that also there is a loss of energy. The type of loss is termed as loss of head due to obstruction in pipe. Next is loss of head due to bend in a pipe. This is the most common type of loss you can observe even at your home. If you have gardens and all, what you will do at the time of watering the plant, there will be sudden bending of pipe due to which the pressure of the pipe is reduced. That is known as loss of head due to obstruction in a pipe. Loss of head due to bends in a pipe. Last but not the least, loss of head in various pipe fittings. If your pipe fittings are not properly done, then also there will be loss of energy due to pipe fitting. Now we will see what are the formulas used to calculate loss of head due to obstruction in a pipe. So loss of head due to obstruction in a pipe is calculated using the formula H is equal to V1 minus V2 whole square by 2G. So if you do the expansion for it, it comes out to be V1 square plus V2 square minus 2 V1 V2. So you only have to remember HE, that is loss of head due to expansion of pipe is nothing but V1 minus V2 whole square divided by 2G. Similarly, loss of head due to sudden contraction, how you are calculating? HC is comes out to be K into V square by 2G or 0.375 V1 V2 square by 2G. If the value of Cc is not given, then the head loss due to contraction is taken as Hc is equal to 0.5 V2 square by 2G. So there is a big difference between loss of head due to sudden expansion of pipe and loss of head due to sudden contraction of pipe. In case of expansion of pipe, we use the formula V1 minus V2 whole square divided by 2 times V1 V2. Whereas in case of loss of head due to contraction, Hc is equal to 0.5 times V2 square by 2G. Now we will solve a problem on loss of head due to sudden expansion of pipe. So what we are assuming, just listen, just see the problem or read the problem once. Find the loss of head. You need to calculate loss of head. Find the loss of head when a pipe of diameter 200 mm is suddenly enlarged to a diameter of 400 mm. क्या मालूम करना है आपको? लॉस ऑफ हेड HE यूनिट टू कैलकुलेट व्हेन ए पाइप जिसका डायमीटर पहले 200 mm था अचानक से बढ़ा कर दिए 400 mm. तो कितना लॉस ऑफ हेड हो रहा है? वी नीड टू कैलकुलेट. द रेट ऑफ फ्लो ऑफ वाटर थ्रू द पाइप इज 250 liters per second. So the discharge through the pipe is given as 250 liters per second. So diameter of smaller pipe D1 is equal to 200 mm. So it comes out to be 0.2 meter. Now area is equal to A1 into pi by 4 D1 square. So D1 is known to you 0.2. Using that you calculate A1. So it comes out to be 0.03141 meter square. Similarly, diameter of larger pipe D2 is equal to 400 mm. That is also given to you. So it comes out to 0.4 meter. So your 8 is equal to pi by 4 into 0.4 square. So it comes up to be 0.12564 meter square. Next, discharge Q is equal to 250 liters per second. So you convert this into meter square per second, it will go to cube per second. Just divide by 1000. So it comes out to be 0.25 meters cube per second. So your velocity V1 is equal to Q by A1. Q is how much? 0.25. A1 is 0.03141. So it comes out to be 7.96 meters per second. Similarly, V2 is equal to Q by A2. Q is given to you as 0.25. divided by A2 is 0.12564. It comes out to be 1.99 meter per second. So now the loss of head due to sudden expansion of pipe is given by H is equal to V1 minus V2 whole square by 2G. V1 is nothing but 7.96, V2 is nothing but 1.99. G is 9.81. So your HE comes out to be 1.816 meter of water. Apart from these basic minor losses, that is loss of head due to sudden expansion of pipe, loss of head due to sudden contraction of pipe, other types of losses are there, such as loss of head at the entrance of the pipe. HI is given by 0.5 V2 square by 2G. Even in competitive exams, it is asked. Loss of head at the exit of the pipe, HO is equal to V2 square by 2G. So if you observe carefully, both the formulas are almost same. Loss of head at the entrance of the pipe and loss of head at the exit of the pipe. Only the difference is with respect to 0.5. Similarly, loss of head due to obstruction in a pipe. How you will calculate? See here. Head loss due to obstruction in a pipe is given by V2 V square by 2G under the bracket A divided by CC minus A minus 1 whole square. So it is very complicated. You just try to remember the formula at least while solving the problem. It really helpful. Loss of head due to bends in pipe. How you will calculate? HB is equal to KV square by 2G, where HB is the loss of head due to bend, V is the velocity of flow, K is the coefficient of bend. So the value of K depends upon the angle of bend, radius of curvature of bend, diameter of pipe. So these are the factors on which the value of K depends. Next is loss of head in various pipe fitting. So loss of head is also due to various pipe fitting. It also comes out to be K into V square by 2G, where V is the velocity and K is the coefficient of pipe fitting. Now we will solve a problem on this. Water is flowing through a horizontal pipe of diameter 200 mm at a velocity of 3 meter per second. So what is happening? Water is flowing through a horizontal pipe. वो पानी है आपका हॉरिजॉन्टल पाइप से बह रहा है जिसका डायमीटर है 200 mm and the velocity of flow of water is 300 per meter second. 300, sorry, 3 meter per second. What is happening? A circular solid plate of diameter 150 mm is placed in the pipe to obstruct the flow. What is happening inside the plate? A circular solid plate of diameter 150 mm is placed in the pipe to obstruct the flow. So what you need to calculate? Find the loss of head due to obstruction in a pipe if CC is equal to 0.62. So you need to calculate obstruction in a pipe. Loss of head due to obstruction in a pipe. So what are the things given to you? Capital D is given to you. Diameter, it comes out to be 0.2 meter. Next velocity is 3 meter per second. Another area of pipe is pi over 4 into d square. It comes out to be 0.3141. Diameter of obstruction D is equal to 150 mm or 0.15 meter. Next area of obstruction A is pi by 4 into d square. D is already known to you 0.15. If you do the calculation, you will get the value easily. So CC is 0.62. So using this equation, that is loss of head due to obstruction in a pipe is given by V square by 2G into the bracket A divided by CC A minus alpha minus 1.0 raised to square. So V 3 velocity is nothing but 3 into 3. 2 into G is 9.81. Area is 0.03141. CC coefficient of contraction is 0.62. Again, A is 0.03141 minus of small a. It is 0.1767. So what is this small a or alpha? You just see here. Alpha, no, it is area of obstruction it is. Area of obstruction pi by 4 into d square. So if you do the calculation, you will get the value of loss of head due to obstruction in a pipe equal to 3.311 meter. Now we need to understand what do you mean by hydraulic gradient line and total energy line. So the concept of hydraulic gradient line and total energy line is useful in the study of flow of fluids through a pipe. Hence, they are classified as hydraulic gradient line. It is defined as the line joining. It is defined as the line joining which gives the sum of pressure head and datum head of a flowing fluid in a pipe with respect to more reference line or it is B, and which is obtained by joining the top of all vertical cord showing the presence and flowing fluid in the pipe from the center of the pipe, briefly written as the GL hydraulic gradient line. So how we are defining hydraulic gradient line? It is defined as it is defined as the line which gives the sum of pressure head and datum head. It is hydraulic gradient line is P by W plus Z. It is a line which is obtained by joining the top of all vertical ordinates showing the presence head P by W flowing into pipe from the center of the pipe. It is briefly written as HGL. Similarly, what do you mean by total energy line? It is defined as the line which gives the sum of pressure head, diagram head, kinetic head. See here, don't get confused. The difference between hydraulic gradient line and total energy line. Hydraulic gradient line take into account the sum of pressure head and datum head only, whereas what you can say total energy line takes into account all the factors. It takes into account what you can say the kinetic head. It takes into account the pressure head. It takes into account the datum head. The summation of all the three is termed as total energy line. So next topic which we need to understand is flow through pipes in series, or it is also known as compound pipe. So which type of pipes you will call it as in series? Pipes in series or combined pipes is defined as pipes of different length and diameter connected end to end in series to form a pipeline as shown in the figure. So what is happening? How we are defining the figure? So how we are defining flow through pipes in series or through compound pipes? बंद कर अपनी बच्चों so how you are defining pipes in series or compound pipes is defined as ऐसे पाइप जो कि लेंथ अलग है और डायमीटर अलग है लेकिन कनेक्टेड एंड टू एंड so that's why the name pipes in series. So what we are assuming, let L1 L2 L3 is equal to length of pipes 1 2 and 3 respectively, different length of pipe. Similarly, D1, D2, D3 is the diameter of pipes 1, 2, 3, and 3. We are assuming three pipes are there which are connected end to end. L1, L2, L3 is the length of these three pipes. D1, D2, D3 is the diameter of these three pipes. Similarly, V1, V2, V3 is the velocity of flow through the pipes. And F1, F2, F3 is the coefficient of friction of these pipes. And capital H is nothing but difference of water level in the two tanks. So now the discharge through each pipe, the discharge through the discharge passing through each pipe is same. Next, which is equal to Q equal to A1 V1 is equal to A2 V2 OH theta. Now we have difference in liquid surface is equal to sum of total head in the pipes. So your F is equal to the difference in liquid surface is equal to sum of total head. I is equal to loss of head at the entrance 0.5 v1 square by 2g plus loss of head due to friction 4 f1 l1 v1 square by d1 into 2g plus 0.5 v2 square by 2g contraction plus 4 fl2 l2 v2 square d into 2g plus v2 minus v3 whole square by 2g plus 4 f3 l3 v3 square by d3 into 2g plus v2 square by 2g. If minor losses are neglected, then the equation becomes if we neglect the minor losses, that is loss of head, obstruction of pipe, loss of head at the entrance of the pipe. All these things we assume what will happen is If final access is calculated, H is equal to 4 F1 L1 V1 square by D1 into 2G plus 4 F2 L2 V2 square by D2 into 2G plus 4 F3 L3 V3 square by D3 into 2G. So if the coefficient of friction is small for all pipes, what we can do, we can assume that F1 is equal to F2 equal to F3 equal to F. So if you substitute the value of H is equal to, then it becomes 4F L1 V1 square by D1 into 2G plus 4F L2 V2 square by D2 into 2G plus 4F L3 V3 square D3 into 2G. So 4F by 2G can be taken out. So it becomes L4 H is equal to 4F by 2G L1 V1 square by D L1 V1 square by D1 plus L2 V2 square by D2 plus L3 V3 square by D3. So this is the final equation for loss of head due to friction in the pipe when the pipe is connected in series. Now we will solve a problem on this. The difference in water surface line in two tanks which are connected by three pipes in series of length 300 mm, 170 meter and 200 meter and of diameters 300, 200 mm and 400 respectively is 12 meter. Capital H is given to you. What you need to calculate? Determine the rate of flow of water. Coefficient of friction is also given to you. Minor losses, negative minor losses. So what is given to you? Difference of water level. Capital H is given to you as 12 meter. L1 is given to you. L2 is given to you. D1 is given to you. D2 is given to you. L3 is given to you. D3 is given to you. And F1, F2, F3 is also given to you. F1, F2, F3 is also given to you. Now, considering minor losses, V1, V2 are the velocities of first, second, and third pipe. From continuity equation, A1, V1 is equal to A2, V2 equal to A3, V3. So, with the help of this, V1, V2, and V3 is calculated. So, V1 comes out to be 1.407 meter per second. So, using this, will discharge is nothing but area into velocity A1 into V1. So it comes out to be 99.45 liters per second. And if you neglect the minor losses, H is equal to this equation. H if you substitute, then V1 finally comes out to be 1.445 meter per second. So the discharge Q is equal to V1 into A1. V1 is 1.445 into pi by 4 into 0.3 square. So it comes out to be 0.1021 meter cube per second. So finally, the equation discharge Q is equal to 102.1 liters per second. This problem is somewhat lengthy, but it is very important. So in the next class, we will see some other type of problem and equivalent pipe duplets problem, pipes in parallel also we will see. I hope you have a good time. If you have any doubt, you can just comment on it.